Am I the only one that didn't know computers could break the rules of physics? When I first heard about quantum computing, I thought it was just another tech buzzword, something only scientists in lab coats would ever need to worry about. But the truth is, quantum computing is set to change the world in ways most of us can barely imagine. It's not just a small upgrade to the computers we use every day, it's a complete reimagining of what computers can do and how they do it. If you've ever wondered what all the fuss is about or why people get so excited and sometimes a little nervous, when they talk about quantum computers, you're in the right place. Quantum computing isn't just clever maths, it's a whole new way of thinking. Imagine a world where computers don't just follow the rules, they rewrite them. Instead of being limited by the boundaries of classical physics, quantum computers tap into the strange, almost magical world of quantum mechanics. This is the science that explains how the tiniest particles in the universe behave, and it's full of surprises. Quantum computers use these surprises to do things that would be impossible for even the fastest supercomputers today. Let's break it down together. So you know how normal computers work with bits? If you've ever used a computer, a phone, or even a digital watch, you've already been using bits. Those tiny pieces of information that are the building blocks of all digital technology. Every photo you take, every message you send, every website you visit is made up of billions and billions of bits, all working together behind the scenes. Each bit is like a tiny switch. It's either on or off, a 1 or a 0. Think of it like a light switch in your house. It can only be in one of two positions, on or off. In the world of computers, these positions are called 1 and 0. By combining lots of these on-off switches, computers can store information, perform calculations, and run all the apps and programs we rely on every day. It's simple, but incredibly powerful. Simple. But quantum computers use something called qubits. Now this is where things start to get really interesting. Qubits are the quantum version of bits, but they don't play by the same rules. Instead of being stuck as a 1 or a 0, a qubit can be both at the same time, thanks to the weirdness of quantum mechanics. This ability to exist in multiple states at once is what gives quantum computers their incredible power. Here's the mind-bending bit. A qubit can be a 1, a 0, or both at the same time. This is called superposition, and it's one of the most important ideas in quantum computing. Imagine you're flipping a coin. In the classical world, the coin is either heads or tails when it lands. But in the quantum world, it can be both heads and tails at the same time, at least until you look at it. This means that a quantum computer with just a few qubits can process a huge amount of information all at once, far more than a regular computer with the same number of bits. Imagine flipping a coin that's both heads and tails until you peak. That's the magic of superposition. It's as if you could do every possible calculation at once, and then, when you check the answer, you get the one you need. This is why quantum computers are so powerful. They can explore many solutions to a problem at the same time instead of trying them one by one like a regular computer. That's called superposition. But there's another trick up quantum computing's sleeve: entanglement. This is where things get even stranger. When two qubits become entangled, they form a special connection. No matter how far apart they are, changing one instantly changes the other. It's as if you had two magic coins, and whenever you flipped one, the other would always match even if it was on the other side of the world. But it gets stranger. Qubits can be entangled. Basically, they're linked, so what happens to one instantly affects the other, even if they're miles apart. This phenomenon baffled even Einstein, who called it spooky action at a distance. But for quantum computers, it's a superpower. Entanglement allows qubits to work together in ways that classical bits never could, making quantum computers even more powerful and efficient. It's like having a magic pair of dice that always roll the same number no matter how far apart they are. This means quantum computers can solve certain problems much faster than any traditional computer ever could. For example, they can search huge databases, simulate complex molecules, or crack codes that would take classical computers millions of years to break. Now you might be wondering, what does all this mean for me? Well, the potential applications of quantum computing are almost limitless. Imagine being able to design new medicines in days instead of years, or create materials with properties we've never seen before. Quantum computers could help us solve some of the biggest challenges facing humanity, from climate change to cybersecurity, to understanding the mysteries of the universe itself. So why does this matter? Quantum computers can solve problems that would take a normal computer years, in minutes. For example, let's say you wanted to find the best route for a delivery truck to take through a busy city. A regular computer would have to check every possible route one at a time, which could take forever if there are lots of stops. But a quantum computer could check all the routes at once, finding the best one in a fraction of the time. Stuff like cracking secret codes, finding new medicines, or even helping fight climate change. Quantum computers could revolutionize fields like cryptography, making our data more secure, or, if we're not careful, making current security systems obsolete. They could help scientists simulate the behavior of molecules, leading to breakthroughs in drug discovery and materials science. And by processing massive amounts of data quickly, they could help us understand and combat global challenges like climate change, disease outbreaks, and more. But before you start worrying about your laptop becoming obsolete, let's put things in perspective. Quantum computers aren't going to replace your home computer or smartphone anytime soon. They're designed for very specific types of problems, ones that are too complex for classical computers to handle efficiently. For everyday tasks like browsing the web, writing emails, or streaming videos, classical computers are still the best tool for the job. But don't worry, you won't have a quantum laptop anytime soon. In fact, quantum computers are still in their early days. Most of them are huge, delicate machines that need to be kept at temperatures colder than outer space. They're incredibly sensitive to their environment, and even the tiniest disturbance can cause them to lose their quantum magic. These machines are still in labs, kept super cold. Scientists use special refrigerators called dilution refrigerators to cool quantum computers down to just a fraction of a degree above absolute zero. That's colder than the vacuum of space. This extreme cold is necessary to keep the qubits stable and prevent them from losing their quantum properties. But the race is on, and the future could be mind-blowing. All around the world, researchers and engineers are working day and night to make quantum computers more powerful, more reliable, and more accessible. Companies like Google, IBM, and startups you've never heard of are pouring billions of dollars into quantum research. Governments are investing too, hoping to be the first to unlock the secrets of quantum technology. Now you know, quantum really is the next big thing. As we stand on the edge of this new technological revolution, it's important to remember that quantum computing isn't just for scientists or tech companies. It's a field that will touch all of our lives in ways we can't even predict yet. Whether it's making our data safer, helping doctors cure diseases, or unlocking the mysteries of the universe, quantum computing is opening doors to a future full of possibilities. So the next time you hear someone mention quantum computers, you'll know exactly what they're talking about, and maybe, just maybe, you'll be as excited as the scientists racing to build the future.